share these notes in a future year. So this is just the first notes in the heat unit, and we're basically using the note sheet that you got from the sub that you have. And I want to go ahead and use my document camera here. Okay, so you have this side for your notes, and this is what we're going to fill out. We also have some unit conversions here on calories and joules, and we have then I'll go through that a little bit because there's going to be a little bit of math with doing unit conversions. Okay, you're familiar with food calories, but we also are going to introduce the science calorie, which is similar to the food calorie that you're used to, having 2,000 food calories, but a science calorie is actually a little smaller, 1,000 times smaller. And so every time you have a calorie, or you take 2,000 calories for your food every day, it's really 2 million of the science calories. So instead of doing it metric and then put it in a metric unit, they actually call it a big C calorie for the food calories that you're used to using every day for your food. So anyways, there's going to be 1,000 to 1 units that we're dealing with. And then we have the metric unit, which is 4 joules for every small c, which is a science calorie, or 4,000 joules for every food calorie that you're familiar with. So I'll be a little bit of math involved with that, but I hope to get that through you with the lesson. But this whole page is your notes. This whole page is your notes, and we're going to go through the words and vocabulary and whatnot. And then we're going to be going and having you work on the other side, which is a homework assignment. But I'd like you to finish and try to match up the terms and hopefully get through 1 or 2 of these. You definitely can fill out number 9. We'll go through that in the video. But I'd like you to, and maybe probably showing you number 10. But I also like you to try to do at least record, 10, 11. If we get to 12, I hope. Anyways, what I'm saying is I'd like you to complete as much as you can this period and then turn this paper in so you guys can get credit for your effort today. Okay. Now let's go ahead and get started with the notes. We have it based on heat and energy and chemistry. We're going to talk about heat, and it is a form of energy, but it's mostly like a form of transferring energy from particles to particles. And we'll explain all that the next couple weeks. Okay. So let's actually get into the terms. I've got it all typed up here. Okay. So, and I've got it even enlarged. So let's go ahead and use my enlarged copy. Okay. So here at the very beginning is that you're going to write down energy is the ability to do work or to give off heat, give off or absorb heat. Okay. And we're going to talk a lot more about heat in chemistry. But when you do energy with like a lot of physics type lessons, or even some of the chemistry lessons of a higher level, you might be doing work as well. So we're basically going to be focusing on the heat part of it, but you could do some work in chemistry as well. That's the whole essence of running engines and things like that. But again, we're not going to get too technical. Okay. Obviously, you guys should know the 2 types of energy. There's kinetic and potential energy. We're going to focus in on the chemistry systems of energy. And so we're going to absorb kinetic energy in the form of the motion of particles. It is a direct measurement or directly measured by the temperature. So temperatures are really big word, vocabulary word. If you have increased motion, because you always think of kinetic, like the energy of motion, the increased motion is equal to the increased temperature. And then the opposite is also true, that the lower the temperature, lower the motion. Okay, so when we have kinetic energy, it's going to be the motion of the particles, which we directly measure by its temperature. Okay, even down to the lowest temperature of the really coldest temperatures, you even have some energy. It's just really, really, really low temperature. Now we basically are at around, I don't know, we're going to talk about in the Kelvin units, but again, I'll talk more about temperature when we get back, but basically know that temperature is a direct measurement of the kinetic energy of the particles, okay? We also can doing the potential energy of chemistry too, but it's going to be inside the composition of the chemicals, and it's going to be called the chemical potential energy. This is all based on the type of atoms that's in the molecules. And we're only just starting to talk about the atoms, but we're also eventually going to talk about the atoms first, and then we're going to be talking about the bonds itself. I'll show you some of the bonds so far, but we're really going to get into the types of atoms, what the elements are, how they bond. But the bonding between atoms and the arrangement of these bonds, this actual number of the bonds and the actual arrangement of these bonds is going to be a measurement of the potential energy or the stored energy in the actual composition of the molecules. Okay, so you're basically writing down chemical and potential, what the definition of energy is, understanding that kinetic is temperature, but potential energy is what's in the bonds and the type of bonds. Okay, so the potential energy stored in the bonds can be given off in the form of heat. Okay, and in fact, energy is just transformed into different forms. Okay, that means that we cannot create it or destroy it. It's only a matter of transferring into the actual particles that we have. That's where the stored energy is, and the fact that they break and form in chemical changes and physical changes, that is that flow of the heat, the flow of the energy is what we're looking at. And so this not being created or destroyed is the first law of thermodynamics, which you guys have heard of, the law of conservation. And you've heard it as the law of conservation of mass, where mass is not created or destroyed, but it's also the law of conservation of energy. Okay, so in your notes so far, you should be almost like halfway down on the front sides. So as I'm kind of talking here a little bit, let's make sure you got the first part down, and it is basically about halfway down, and you should see this potential energy is given off as a form of useful work. That would be like running a car or a motor or a turbine. That would make it really useful, but we can still just give off heat, you know, and make us feel warm like a fire. Or we can actually have the engine, like our air conditioner, give us off heat or absorb heat to make it air conditioner work. Okay, so let's actually talk about the units of energy as it applies to chemistry, and we're going to write that down and get into the actual difference between temperature and heat. So let's move on here. Okay, and we're going to be looking at these units, and we actually need to write them down here. I didn't have them enlarged on a sheet of paper. So right here at the units of energy as applies to chemistry, it's usually in the form of heat lost or gained in three general processes, okay, such as chemical reactions, which we're going to be doing later in February, March, okay, through the changes in state of a substance, which we've actually already done recently, earlier in August, September, but we're going to do that a little bit, or at least talk about change in state, and then also an exchange of heat between materials. So we're really going to be doing 2 and 3 to some degree here in this current semester. We're going to do a lot more of chemical reaction heat next semester, okay? So let's actually talk about heat, okay? And I got this blown up a little bit better because I really want you to see the actual definitions a little bit more, okay? And hold on a second, I had it here. Yeah, here we go. Okay, so we have heat as the energy flowing or transferring from a warmer to a colder object, and it ultimately results in a change in temperature, usually, okay? The energy flowing is a big thing. Energy flowing is heat, and it's actually transferring always from a warmer to a colder. Something warmer is making something, is transferring it to cold. So it always goes from warm going to cold, warmer going to colder, okay? Warmer going to colder, okay? Now, remember ultimately that anytime we do anything, the heat lost is always equal to heat gain. That's the transfer. That is the law of conservation of energy. Okay, we don't really lose it, but if we do lose it, it would be we don't really lose it. It just goes out to the environment if we can't all transfer it into work, useful work. But usually, all the heat loss is theoretically all going to heat gain from the law of conservation of energy, just like the law of conservation of mass. Okay, and the ultimate phrase is that heat loss equals heat gain. Okay, now again, what is heat? It's the energy flowing between the warm to the cold, and usually results in a change in temperature. It's really based on the amount of mass and also the change in temperature. Okay, these are considered, heat units are considered derived because you have to calculate it, and we'll be doing a lot of that during this unit. Okay, so heat is a reflection of temperature, but it's usually a change in temperature going from warm things transferring it to cold things. Okay, now let's actually talk about what temperature is. Okay, like we said, it was a reflection of your kinetic energy. Okay, so let's look at temperature next. We've got heat. We talked about heat, the actual three things we're going to do in the course with chemical reactions, state changes, and just exchanging between materials. And then we defined heat, and now we're going to define temperature. Okay, temperature is a direct measurement of the average kinetic energy of the particles involved in the heat exchange. Okay, it's a direct measurement of the average kinetic energy of the particles. Okay, so when we record temperature, if you have a high temperature, then you have a higher kinetic energy. If you have a lower temperature, you're going to have a lower kinetic energy. The other thing to remember that I didn't mention yet is that heat has a symbol that we have in our equations. It's going to be the letter Q, okay? We're going to use temperature with the letter T, and a lot of times it's going to be the change in temperature. So what we're going to have is we're going to usually see it as a delta with change in T. We're going to use that. We're also going to use mass in our equations, and that's going to be given in the letter M like you've used to in the past. So we're going to use change in temperature. We're going to use mass. We don't need three S's. I'm sorry about that. And it's going to be the letter Q. So all these letters we're going to be using, okay? So let's just make sure you had a chance to write these all down, okay? You got to write down the three parts about what we were talking about. What is the way does it apply to our course? And it's going to be in this usually in the form of heat lost or gained through chemical processes such as chemical reactions, through changes in state, or exchange in heat between materials. Okay, so make sure those are written down. We're going to do these two right now with our unit. We're going to do this later next semester when we actually get into chemical reactions. Okay, now heat is this energy flowing or transferring from a warmer to a cold. Let's go ahead and put a parentheses there. So it's just flowing or transferring from warmer to colder object, and ultimately usually in a change in temperature. Okay, it's also based on the amount of mass, and that heat is a derived unit. You have to calculate it, and we'll be doing calculation math later on how to actually get heat. Okay, then we have the temperature definition. This is the measurement of the average kinetic energy of particles. It's involved in the heat exchange. So it's a direct measurement of the average motion kinetic energy. It's directly proportional. That's what this little fish thing is. It's a proportionality thing. It's also can be a general definition of how hot or how cold something is. This is probably what you're used to knowing, but this is a more official definition. You could use both, but we want to always remember that temperature is an average kinetic energy of the particles. Okay. Now, the last part of our notes, if you look at your note sheet, is just using this units of heat. They're already written out, but we're going to use calories, and calorie is a science calorie, and that is actually only a portion of a food calorie. And this is the amount of heat needed to raise only 1 gram of water up or down 1 degree Celsius. So a little tiny bit of water, going up 1 degree Celsius. It's very little to heat up 1 little gram. That's a 1 little cubic centimeter, okay? So this science calorie was first designed, and they applied it to actual food calories, and food calories have a capital C. The science calorie has a small c. And because America didn't want to do anything with metrics being 1,000 times bigger for the science calorie, they went ahead and just capitalized this science calorie to the food calorie, the unit that we're used to, okay? So really 1,000 science calories is the same as a food calorie, and a science calorie is one of those for every 4 joules, a little bit over on 4 joules. And joules is the actual metric unit. When the actual metric system came to be, a joule ended up being about 4 times more than a science calorie. The calorie itself was made first, and I can explain a little bit more about the history of that later, but the actual science calorie was first, the food calorie came after that, and then they adapted it to the metric system with mass and liters and all those other units. And it's actually 4 times more. So we're going to use these conversions, okay? So let's actually do that, and I'll help you with the second half of your homework, okay? From our notes so far, you should be able to tell me what number 1's definition is, what it comes from, the actual energy. This is the law we went over. This is the actual definition of the flowing of energy. We just went over that definition. The actual study of heat changes is actually the thermochemistry. That's the answer for 4. When you store energy, that is, remember, that's potential, okay? The amount of heat required to raise the temperature 1 gram, which is what I just went over, that's a definition of a small c calorie, okay? And then the insulated device, that's actually something I didn't even mention yet. That's called a calorimeter. I didn't go over number 7. I didn't go over that device. You're going to make that A. You're going to make the actual study letter H. And then the actual metric unit is in there. So all the other ones you should be able to get from the notes. So you figure out those letters and figure out that definitions, okay? But let's actually look at how to do these questions 9 and maybe do 10 and 11 if we get to 12. I don't want to go much later because I don't want to make this video so long. You won't have time to do the actual worksheet, okay? So when you read the labels, they usually have, and this is kind of small here, I tried to make a better copy, but they usually have the big C calorie, and that's 120. It represents 6 cookies. That's 6 cookies. So 120 is a big C calorie from those 6 cookies. Okay, that's your answer for number 9. Okay, I actually enlarged this on another sheet of paper because I don't want to ruin this original copy, but you're going to use a big C calorie to go to joules, and you're going to use 4,000 joules for every big C calorie to help you with number 10. You're going to use the same thing, but in reverse for number 11. So you're going to use this conversion for 10 and 11. And then you're going to be doing science calories. I'm sorry, my picture's in the way there. Science calories, food calories, and that's a matter of taking these guys and just dividing it by 1,000, okay? Dividing it by 1,000. Because there's 1,000 of these for every one of these. Science calories are 1,000 times. You need 1,000 of these for every one of these. So you literally just take this and divide by 1,000. Okay, you go ahead and try the math out. You probably will get 25 for the answer for 12. Okay, so let's actually run through an example of 10 or 11, and you try to do the other way. Okay, let's do that right here on my next sheet of paper. Okay, so I have it all written out. With number 9, what was the nutritional facts? The label itself says it is 120 big C calories. So I'm going to capitalize that, big C calories. Okay, big C calories is thousands of small c. And a big C calorie is a food calorie like you see on the packaging, okay? How much energy in joules is by eating these 6 calories? Now remember it says a big C calorie is equal to 4,184 joules, because a big C calorie is thousands of the science ones. So we're going to make this 4,000 joules, okay? So we have 120 calories in those 6 cookies. And since we want to go to joules, remember how we put the joule unit on the top? We're going to multiply, because we're going to put the 4,184 joules on the top, 4,184 joules on the top for every big C calorie. So literally for every food calorie, 120, we're going to make it a big, big number in joules. We're literally going to just take 120 and times it by the 4,184, and that's going to be a big number. You see here, I've got my phone nearby, get that calculated, okay? And we've got it here with the calculator, okay? And so we have 120, excuse me, let's clear this. 120 timesing it by 4.184. Oh man, my calculator, sorry guys. 120 times 4.184, and it's actually 4,000. So one more time, sorry about all this. 120 timesing it by, again, excuse me on my calculator here. 120, we're going to times it by 4,184. See how I have 4,184 times 120? It's going to be quite large. It's going to be 500,000. 500,000 and 502,000. Okay, let's go ahead and put that down. 502,000. That equals 502,000. Don't worry about the extra 80 because it's only got like 2, 3, 6 big. So that's what our answer is. Okay. Then you're going to take millions of joules and you're going to go back to the big C calories. So guess what we're going to do? We're going to inverse the factor, and you do the math to come up with how many calories. Obviously, if you're going to do the reverse, you're going to flip this and divide by 4,184. So why don't you guys do that? And then I orally went over this answer. Remember that there's 1,000 science calories. These are science calories on, sorry about my here. Okay, you guys do number 11. Remember, it's the opposite here. We're going to divide by 4,000 for this question. The next one I mentioned earlier, because it's 1,000 science calories for every one big food calorie. Every time you have a calorie of food, it's going to be 1,000 science calories. And now remember that science calories have a small c. It's a small c letter. But this food calorie is a capitalized calorie, a big capitalized C calorie. And it's just because America didn't want to make it a kilocalorie. Okay, so this is the capital calorie, that is a food calorie. Okay, so all we're doing is taking this and dividing it by 1,000 because we're going to get rid of our science calories and go to calorie. You guys also try to set that up and show me your answer here. Show me your answer for here and show me your answer for here. Show your work here, show your work obviously on your paper. So you're going to show your work here and here and here for the 3 problems, and then try to turn your paper in. And then if it's not, at least try it and get a paper turned in, and then we'll go over more conversions on the next day we're together. Okay? Let me know if you have any questions. Text me on Remind anytime you want if you need help. Okay? We'll see you later.